Okay, we're still in exercise set 69, and we're doing problem 21 now. And again, my impression is hopefully you're able to do most of these problems without further assistance. But for those students that need the further assistance, I put a blue area down of my work. It's really work for well-prepared students. In other words, if you're well-prepared, you look at that work and say, oh yeah, just what I did. Although maybe not exactly what you did, maybe something similar, maybe did something better. Who knows? All right, I don't know. What I'm going to claim, though, some students do need more support, like, that teacher at the board, so to speak. So what I want to do is go to the board. All right, so I'm going to do that now. I'm done with this. This is problem number 21. And I'm going to go to the whiteboard. And let me put that down for you. And we're on problem number 21 now. And it's really an infinite sheet of paper, by the way. And I'm doing 21, right? And so, someone says, do you remember what you read? Absolutely not. So what I'm going to claim is I have to look at it, and I hope you're looking at it too. And what I know is there's a path between P and Q. This is where P is, and this is where Q is. Now, by the way, when I say it's a path, I'm very simplistic in my drawing. I'm going to make it a line like this, all right? Now, what do I know? I know that A starts from P and he travels to Q. So A is here, he's going in that direction. And then what does it go on? It says that B travels from Q to P. It goes like this. And they leave at the same time, and they're uniform motion problems, which makes it so much easier for me to deal with. But what do they say? A reaches Q in 8 hours, right? And B reaches P in 18 hours after they met on the road. So I'm going to understand, just kind of reading that, I'm going to say they probably met over here. And it took them 8 hours to get there. So I'm going to say X equals the number of hours to meet. Right, number of hours to meet. And it's not the most difficult thing in the world, but they met there. All right, they met there. All right. Now someone says, why do you put it closer to P and Q? Because it goes on to say that B took 18 more hours. So how much time would B take? His time would be, well, it took him 8 hours to get here. I'm sorry, I didn't mean to say that. Let me erase it. It took him X hours to get there. And then, right, let me read that again to you. It took 18 more hours to get to P. And he covers the entire path. This entire path would be covered. That's his time. So I'm going to say time of B. And what's time of A? Let's take a look. Well, it took him X hours to get to the meeting location. And then it took 8 more hours to get to the final destination of Q. All right? So I want to claim, I got something over here. I got a distance equals a rate times a time problem. So what I want to do is I want to set an arbitrary distance over here. And I just don't know what the distance is, by the way. They didn't say it. So I'm just going to say this is 1 unit. All right, 1 unit. That's a distance. And the time is in hours. So the rate is going to be unit. How many units they can do in an hour. All right, I just don't know what the unit is. So let's write this down. So the distance equals the rate times the time. Well, I said the distance is 1. The rate, I don't know. The time is X plus 8. So what's the rate for this? This, by the way, this is the rate of A. Sorry about that. And this is time of A. Distance is still 1, regardless of whether it's A or B. So what do you get over here? 1 unit every X plus 8 hours. And this is the rate of A. What's the rate of B? Same thing. The distance is equal to the rate of B times the time of B. Well, the distance, I arbitrarily said it's 1 unit long. It doesn't matter what the unit is at this point. The rate of B, no idea. What's the time of B? X plus 18. What do you get over here? 1 unit every X plus 18 hours is the rate of B. Now, by the way, I could understand people getting stuck right now and saying, I have no idea what to do. Well, I think you probably, if you gave it some thought, I want to emphasize what I mean by giving it thought, that they basically cover, that's what B covered in X hours. And this is what A covers in X hours. So I'm going to write the formula down. And what is it going to be? Well, it's going to be rate times time. Let's write that down. Rate times time is distance. So what do you get? Let's do A's distance now, where they meet. We're talking about where they meet. Is distance where they meet. It's going to be 1 over X plus 8. That's rate. And how much time did it take them to get to that location of meeting? X hours. Plus, let's talk about B. What's his rate? 1 over X plus 18. And how many hours did it take him to get to that meeting spot? It took 8 hours. They left at the same time. What did they cover? 1 entire unit. They covered the whole space. All right, so I'm at a place for an equation, and I'm kind of thankful for this. And I think probably Wells would have done this problem a little bit differently than I'm doing it, but that doesn't matter. You know, I can't say that my technique is better than Wells's, and I don't think Wells would be of the opinion that his technique is better than anyone else's either. The bottom line is, hopefully you start to realize there's a variety of ways to take the path. All right, what are we talking about? The algebra path. I'm saying this is my path. What I'm going to do, though, is I'm going to simplify it by multiplying both sides by the LCD. And the LCD is going to be X plus 8, X plus 18. All right, what do you get over here? You get X times X plus 18 plus X times X plus 8 equals X plus 8, X plus 18. I got to do some algebra now. And the way I'm going to do it might be different than the way you do it, but the outcome's going to be the same. I'm going to factor an X out. And what do you get? X plus 18 plus X plus 8. I'm going to multiply the other side out. What do you get there? You get X squared. Let's see. 18 and 8 is going to be 26X. And 8 times 18, well, that's 80 and 64, which is 144. I want to simplify both sides as much as I possibly can. So what do you get over here? Well, I notice that this is really 2x. So what I get? X times 2x is 2x squared. And 18 plus 8 is 26, so 26x. And what does that equal? X squared plus 26x plus 144. Well, it turns out to be a pretty simple equation, actually. It turns out to be x squared. I'm subtracting x squared from both sides. And if you subtract 26x from both sides, that disappears, and you get 144. So what's x? X equals plus or minus the square root of 144, which is 12. Now, if I'm not thinking that's my answer, I hope you're giving it some thought, though. And what's x? It's the number of hours it took them to meet. It took 12 hours. End of story. Now, again, my emphasis is this over here. It's fine if you need to watch the videos. I'm hoping they're helpful, all right? Now, granted, you might say to yourself, I want to take a different approach. Regardless, it's 12 hours. I don't care what approach you take. It's always going to be 12 hours, all right? Thank you so much for paying attention.